One of the most common operations any assembly language programmer will ever do is data transfers. There are two kinds, internal and external. Internal data transfers are those that occur within the CPU, so they happen within the CPU. For example, when we copy a register onto another register, that's one case. And the external are when we copy data from the CPU to memory and from memory to the CPU. And in this case, when I mean CPU, I'm talking about the CPU registers. Now, in the internal group for ARM, the most common instruction we will use is move. So let's see move, and I'm going to use the format S conditional RD, operand 2. In this case, it's simple to understand that this is an internal data transfer because operand 2 is going to be a register. So here we need to choose a register, and here we also need to choose a register. The result of this operation is going to be that RD is going to be equal to op2, or according to different notation, RD will take the value of op2. Another format for this instruction allows you to use a constant as that value we want to move into the register. And at first this may seem not internal, because where is this thing? It cannot be inside the CPU, right? Well, it is inside the CPU, because when the move instruction is fetched from memory into the CPU, the immediate 16 will be inside the CPU by the time the execution unit starts to execute the move instruction. This number is going to be copied into an internal register and then copied onto RD. That happens as part of the decoding process for the instruction. This is particularly visible if we are using a pipeline to decode the instruction. Here we need to choose a register, and here we can choose any binary code, 16 bits in length. Now, this is a limitation, because if we can only move 16 bits onto the register, which is 32 bits, then we cannot move anything to the upper part of the register. The 16 most significant bits cannot be set with this instruction. We have, for that matter, move T. Move T is move top. So when we use move top conditional RD immediate 16, we can now move the binary code to the upper part of the register. So if we want to load a 32 bits register with a binary number of any sort, we need to run this in two steps. First, we need to issue a move for the lower part, and then another move for the upper part. We also have the MVN instruction. The MVN instruction has format S to set the flags, conditional RD and op2. This one will make RD take the value not op2. So what's happening here is that for op2 we need to choose a register, and that register is going to be bitwise negated before being stored into RD, and in many cases that can be really useful. Let's move to the external. In the external group we have several instructions, but I want to talk about two of them today. We have the LDR, moves information from memory onto registers, and data is going to come from memory. And we have the STR, where we have the memory will be written from a register. LDR is load register, STR is store register. And notice I'm not writing any format in particular, because these two are a family of instructions. They're much more complex, because in this case you cannot use immediate operands to store or load into the register. The reason for that is because we're working with memory, we need to specify an address. So we need to provide always an address, and therefore we have many different ways in which we can specify that address. In the next video, I'm going to talk about examples on how to use MOV and LDR and STR.